Jai Hind students, today we are going to study the fourth chapter in statistics, presentation of data. So last two chapters we had studied the collection, organization and now we are going to study the presentation of data. So it's on the basis of the voluminous data present in our economy. We are classifying it into, first we are collecting, then we are organizing, then classifying into different forms. That is known as what? Presentation of data. So there are it is in the form of compact form we are presenting it. So its first presentation is textual presentation. So textual presentation, data are presented in text form. So it is just written in the type or typed form, or this type of presentation is ideal when data are not voluminous. So it is good when data are precise. So just by reading the written form we can understand how the what is written about the content. So that is known as what? Textual representation. So another form of representation that we are going to study is tabular representation. So tabular representation, as you know, that it has table formed and a number of columns and rows will be there, and it may be explained in such a way. So next is diagrammatic representation. Diagrammatic means what? The chart form or some representation in tabular form or in what? Pie diagram, pie chart form. Next is graphic representation. Graphic means through graphs and all we can just represent it. So next is, first we are going to study the textual representation of data. So textual representation of data, we have to just understand that it is just in a written form or it will be in a precise manner, and the content, the data that is given, we can understand by reading it. So it's a complete text of representation for comprehension, and but at the same time it enables one emphasis in certain points. So what are the points that is to be noted, that it may be written, and some points that we have to see is suitable. It is suitable when quantity of data is not too large. So it is only suitable when the quantity of data is not too large and one has to go through the complete text for comprehension. So if we have to just go through the complete text for comprehension, then this textual representation is not better. So if just by looking a single sentence we can understand, but written in large form we can't do it. So it's enable one to emphasize on certain points. So it's we can say that it's concluding, it's boring. We can say that it will be boring. So it is not good looking or attractive. But tabular representation, next we are going to see tabular representation. But a tabular representation just that when the data is given in a table form, for example maths, biology, chemistry, geography, economics are certain marks of the students, Chintu, Pintu and Tinku. So if the rows is rows, as you know that it's a horizontal representation and columns are in vertical form. So columns will be in vertical form and rows will be in horizontal form. Just so it is shown here. So it may also have certain qualities that you have to look into it. So first column, you can first row, this blue portion is known as what? Rows. So it has certain rows and columns, and we can say that it has cells, and this the marked portion is cells. Each and every points that is showing here is cells, and by calculating this whole data we can say that it has 3 rows and how much columns. The arrow has been put 5 columns. So it is having 3 rows and 5 columns, and the cells is included as 3 into 5. So each box is known as what? A cell. So this box is known as cell. So it's 3 into 5 equal to 15. So each cell gives information that relates to the attribute. So what is the portion that we are going to study? So that is be represented in cells. So tabular representation has a certain types. So we can say that qualitative data, it is classification in the for tabulation are on the basis of qualitative, quantitative, temporal and spatial. So qualitative, quantitative, temporal and spatial. So what is qualitative? Qualitative we had studied in last class, that is it's a attribute showing the sex, literacy, religion, nationality, like that. For example, it's a showing the quality of the people. So it's known as what? A qualitative classification. So under this method, data are classified on the basis of some social status, physical status and nationality, etc. So it's qualitative aspects. So next is quantitative. Quantitative we can say that when classification is done on the basis of characteristics which are quantitative in nature. So it's quantitative in nature, such as age we can say, height we can say, weight we can say, age, income we can say, etc. These are some of the examples. So next is temporal classification. So it's on the basis of time. Time may be, when the classification is done on the basis of time, it's called as temporal classification. Time may be in hours, days, weeks, months, years, etc. So it may be in years, months, hours, etc. So this is temporal classification. So next is spatial classification. Spatial classification, it's on the basis of place. So when classification is done on the basis of place, it is called as spatial classification. When the classification is done on the basis of place, it's known as spatial classification. That's on the basis of town, block, district, state, country, etc. So these are the classification. The place may be in the form of like this. Next day we are going to see is format of, next is format of a table. Format of a table has table number. So table number is written as it's for the identification purpose. So a table number is assigned to table for identification purpose, and the table number distinguishes one table from the other. So it's we can just distinguish between two tables. So next is title of the table. Narrates about the contents of table. It narrates about the contents of table, and we can just by reading the table we can understand what is the table is about, and we can just it gives a brief description of the contents of the table and should be clear and brief. And we can say that next we can say that captions or columns, which is known as column headings. So at the top of the each column, a column heading is given to explain figures in the column. So this is called the captions. So next is row headings or stubs. So it's like column headings. Each row of the table should be given heading, and that is depicted in blue color, and the heading given to rows is known as what? Stubs. So next is body of the table. Body of the table contains the numerical information. It is the most important part of the table, and we can say that it contains actual data, and what is written inside the table is known as body of the table. And next is unit of measurement. The unit of measurement of the figures in the table should be stated along with the title. So it's just showing numerical representations. And we can say the sources. It refers to the source from where the information is taken. So it's also most important. Next, a footnote. So footnote, it explains specific feature of the data content of the table, which is not a self-explanatory. It is taken from somebody, so that is known as what? A content of the table which is not self-explanatory, so that is known as footnote. So these are the important format of table. So this is important, it may be asked for the exam. Types of diagrammatic presentation. Diagrammatic presentation is into three: geometric diagram, frequency diagram, and arithmetic line graph. So we can just divide it into three. So on the basis of this geometric diagram, so it is divided into two. So it's bar diagram and a pie diagram. And in the frequency distribution, frequency diagram, it's divided into three. So that is histogram, frequency polygon, and ogive. So next we are going to see the each graphs in detail. So first is geometric form. So bar diagram, first we are going to see. Bar diagram are those diagrams in which data are presented in the form of bars or rectangles, and it comprises a group of equispaced and equi-width rectangular bar of each class or category of data. Height or length of the bar reads the magnitude of data. So the lower end of the bar touches the baseline, such as that the height of bars starts from the 0 point. So this is the bar diagram definition. Simple bar diagram, what is that? They are those diagrams which are based on single set of numerical data, and the different items or values are represented by different bars. So you have a different bars and it represents different items. So bars in these diagrams are of same breadth. So they have same breadth and different lengths. So an example of simple bar diagram is given here. So you can see the bar diagram. The following table gives data on literacy rate in India. Present the information in the form of simple bar diagram, that is vertical form. So year is given till 2001, and here literacy rates have been given. So how will you mark that you are going to see here? You have to first take the scale and mark 10, 20, 30, 40, 50, 60, 70. Then you have to mark 18.33 from starting from the point 0. You have to mark 18.33, then 28.33, then 34.3, then 43.5, then 52.21, then 64.84. So this literacy rate you had marked. Example, next question is showing the horizontal bar diagram and vertical bar diagram simultaneously. So the following table gives the data of infant mortality of 6 states. So Delhi, Rajasthan, Punjab, Maharashtra, Kerala, Gujarat is shown here, and the infant mortality rate is given here: 35, 68, 44, 36, 14, 34. So you have to mark in vertical axis, you have to mark here the infant mortality rate, and as I had told you earlier, you have to mark from here, putting the scale here, and you have to give equal space between this. So here you are giving 1 centimeter, then here also you have to give 1 centimeter, and you can plot from down the 35. Then 35 you can have to mark and mention Delhi, and then from putting the scale 0 here, and you have to mark 58, then mention the state Rajasthan here, and Punjab, putting the scale 0 here, you have to mark 44. Here is states shown, and here infant mortality. So like this you can mark a vertical bar diagram, and by horizontal bar diagram we have to state that it has to be shown horizontal bar diagram as the states in y-axis, and infant mortality in the x-axis. So you have to mark from putting the scale from here, you have to mark turn the scale as in horizontal form, and put the scale here 0 and mark 35. Then here by giving 1 centimeter space or 0.5 centimeter space, you have to mark again one bar as 68 and Rajasthan, and here Punjab 44, mark 44 here. Scale 2 should be drawn here, that is 10, 20, 30, 40, 50, 60, 70 up to, and each state you can mark. And this is horizontal bar diagram and this is vertical bar diagram. According to the question you have to draw the diagrams. So next you can see multiple bar diagram. They are those diagrams which shows two or more sets of data simultaneously. Each income and expenditure or import export, birth rate, death rate, and two data or three data will be given. You have to mark the bar diagram by adjoining each other. So you can see generally these diagram are used to make a comparison between two sets or series. So you can see here the question is 540. By marking this we can understand 535. So here in the year 2005 it's shown here. So it's a faculty wide distribution of students. So what is the faculty wise distribution of students? Arts stream is having this type of line, and here you can see the cross type of line is showing commerce, and it's a shaded portion you can see science. So like that you can mark so as I told you, you can just mark 1 centimeter, putting 1 centimeter gap. You can mark the data as you had marked the bar diagram. You can mark one bar, and with the same joining this bar you have to mark next, putting the scale here. You are 0, you have to mark 365, that is 325, and mark here. So here you have to just mark a point, and you have to just calculate by 300. You have to mark 10 like that, 10 gap like that, 30, 300, 310. One dot you have to mark 310. Next dot you have to mark 320. Then a light gap you can mark 325. And here also you can just mark by 0.5 here, 1 centimeter you can get a 0.5 here, no? So you can just mark 250. So 1 centimeter gap, the scale has to be drawn in 100 centimeter, 100. Okay, so it's 1 centimeter equal to 100 students. So like that you have to write the scale, and you can just mark. Hope you understood the multiple bar diagram. Next is subdivided component bar diagrams. They are those diagrams which simultaneously represent total values as well as part values of set of data. To indicate different parts of the bars, these are shaded with the colors. So different parts of a bar must be shown in same order for all the bars of a diagram. So in order to in a order words, in other words, a component bar diagram shows the bar and its subdivisions into two or more components. So you can just see it is just component bar diagram. It's just shaded portions. You had marked the previous one vertically. The same way we have to mark this. So not separating. It's should be joined by putting bars upward, and we have to mark it. So how will you mark the component bar diagram that we are going to see here? So first, as per the data, it's given as food, clothing, house rent, miscellaneous savings. So you have a food. So you have to just mark the scale as 1 centimeter equal to 5,000. So from 5,000 you have to mark 1 centimeter, put 1 centimeter, and 5,000 you mark. Then 10,000, then 15,000, like that you have to increase. So the highest value which is given here is 12,000. So 12,000 till 12,000 only you need. But by adding this you have to find first the total. total, then you have to recognize what is the centimeter that you have to mark here. So it's already given here as 25,000. Then you can just understand that till 25,000 alone the bars comes. Then here it's shown family B as 40,000. Then you can understand that family B will come till 40,000. So if this total is not given, you just total the values and find it and keep it. Then you can just correct the value at last when you mark. So first one is 10,000. Food is 10,000. So family A food is 10,000. So you have to mark from 10,000 one bar. Then you have to mark 12,000 here for family B by giving an interval in between. You have to space to 1 centimeter or 2 centimeter. You can just put a space. Then you can mark a 12,000 here, just above 10,000. You just mark and shade the portion and mark as food. And shade a color, you can just mark a food. And the two colors must be same. Next you have to see clothing. Clothing you have a 5,000. So you have to mark from here 5,000. Then 10,000 plus 5,000, it's a 15,000. So you have to mark a the marker here, the 15 the point 15,000, and draw a bar just above it. And here also it's a 12,000 plus 10,000, it's a 22,000. Then you have to mark just here 22,000, put a bar, then you have to shade. Okay, then mark the shading as clothing. Then similarly house rent here it comes 15,000. No, 15,000 plus 4,000, it's 19,000. So you have to mark till 19,000 and put a bar here. And you have to, it is shown a dotted line, or you can put some color also. Then you can mark here house rent. Similarly this also you have what 22,000 here. So you have to mark the add the 6,000 also. Then you will be adding this this both these three, you will be getting 28,000. So 28,000 should be marked here, just 20 above 25 and below 30 you can mark, and dotted lines you can mark, and house rent you can plot. Next you can see that the 45,000, it's a miscellaneous. So it will be just above this. And by adding these you had got the what 20,000 and 24,500 it will come. Then you have to mark from here 24,500, and you can mark, and it is given a plain, and you can just mark plain as miscellaneous. Similarly you have to mark from here 8,000 above it, and you can mark and share, you can mark miscellaneous. And then you can just see 1,500 here, you can just put 1,500 plus. So you will be getting 2,005 to 25,000. And here also you will be getting, by adding all you will be getting 40,000. Then mark here one bar. Then you can get you can mark it's a shaded portion, and write it as a savings. Okay, so hope you understood the subdivided bar. So as I told you, you have to add and write it, and then mark like this, just above like. Okay, next is pie diagram. In a pie diagram, the data is represented in the form of circle. The circle is divided into sectors or slices such that each sector represents the corresponding proportions or a percentage of total. That is, the relative frequencies are depicted as sectors or slices of the circle. So the size of each sector is proportional to relative frequency of the variable. So its purpose is each visual comparison of the proportion of each variable is shown. Steps to calculate the pie diagram. So that is the steps that we are going to see here. So first step that we are going to see here is calculate the pie chart proportions. So how will you calculate? Calculate each frequency as proportions to total. So P1, P2, Pn. So the calculate the angle for each pie slice or sector. So formula is P1 into 360 degree, P2 into 360 degree and up to Pn into 360 degree. So like that we are going to calculate. Next, draw a circle and draw a radius of the circle. Place the protractor on this circle and plot a point on the circle at the first calculated angle. So you will be getting an angle by multiplying this 360 degree. You have to plot and draw the angle and join this with the center of the circle and first sector of a new radius of now obtained. So now new radius is obtained and from place the protractor in the new sector and plot a point on the circle and next calculated angle. So you will be getting another line, and when you are placing it you will have to place the protractor here with the new radius and then mark the next reading. Then next is each time you add a section, the newly drawn line becomes the relevant radius. So rotate the protractor accordingly, color each segment differently and make the color code key. Mention the frequencies and percentages on each sector. So like that you have to do. Next you can see a tabular column, how you are calculating it. So first the data will be given like this and you have to add the data. So total will be 180. Then you have to divide the each data with each components given here. So 82 divided by the total 138 is equal to 0.6 you will be getting. The next component 32 divided by 138 is equal to 0.2 you will be getting, and 14 divided by 138 equal to 0.1 we will getting, and 1 divided by 138 equal to 0.07 you will be getting. So next you have to find the angle of for the sector representing blood group. So it's blood group, so you have to find the angular representation in the pie chart. So you have to multiply the given data into 360. So for plotting in the circle, so you will be getting 2 and 214, 83.5, 36.5 and 26. So like that I had told you earlier, you can plot the groups and you will be getting the answer. So when totaling these values answer will be 360 degree, and you can just identify that if you have any mistake by calculating it, and if it's greater than that the answer will, the circular plotting will be wrong. So you can just plot as I with the protractor and finish it, and you can send me. Hope you understood the pie diagram. Next classification we are going to look is graph. Graph is a method of presenting statistical data on a special type of paper known as graph paper. Data represented with the help of mathematical graph is known as graphical presentation. In other words, graphical presentation is the presentation of all statistical data on graph paper in the form of line or curves. So advantages are it presents the complex data into simpler and understandable form. It is used for forecasting, interpolation and extrapolation. With the help of graphs, we can study the variations in the values of variables. And disadvantages, it is based on brief information, so it do not shows precise value. It may sometimes suggest wrong conclusions. It shows only measurable tendency of data. Actual values are not always clear from the graphs. It is not of equal significance to all the people. It is difficult for the layman to interpret the graphs. So these are the advantages and disadvantages. In the graph, first we are going to see frequency diagram. Data in the form of a grouped frequency distribution are generally represented by frequency diagrams. Like types of frequency diagrams are histogram, frequency polygon, frequency curve, and ogive. So first, histogram. A histogram is a two-dimensional diagram. It is a set of rectangles with the base as the intervals between class boundaries. So along x-axis it's drawn and with the areas proportional to the class frequency. A histogram is never drawn for the discrete variable or data. So it should be noted. Histogram for frequency distribution are of two types. Histogram of equal class and histogram of unequal class. So how will you draw histogram of equal class, that we are going to see here. Histogram of equal class intervals are those which are based on the data with equal class intervals. A series with the equal class intervals would make a histogram including rectangles of equal width. So you can see the example. The frequency distribution of marks obtained by 225 students of a college is given below. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 30, 45, 55, 60, 35 is the data. So here you have to draw x-axis and y-axis. In the x-axis you will be drawing, as you know, marks, and y-axis you will be drawing the number of students. So here there is no gap or no spaces left between. So you have to just draw within by joining the x-axis and the data. So first you can see it's a 0 to 10. So 0 to 10 as class interval is having no difference. So you have to just join 0 to 10, then you have to mark 30 here, then you have to mark a bar here. Then simultaneously you have to join these two lines and draw next 45 and then draw next that is 10 to 20 the bar, next bar simultaneously with the before the previous one. So like that you have to join and join. You will be getting the histogram. So it's a scale. You can say that 1 centimeter is equal to 10 marks or 10 students in y-axis and 10 marks in x-axis. So this is histogram in equal class intervals. Next is histogram of unequal class intervals. When the data of class intervals are unequal, with the width of the rectangle would be different. The width of the rectangles would be increase or decrease in the size of intervals presenting the data in the form of graphs, frequencies, and unequal class intervals suggested. So how will you draw this? You will be seeing here. So you can say that here 0 to 10, 10 to 20, 20 to 30 is the data is going in same direction. Intervals are same 10. So here just you can see 30 to 40 one interval is there. Then 40 to 50 another interval is there. Next you have to mark 50 to 60 next interval. So here three intervals have been come together and it has been the number of students have been marked as 18. So first you have to divide this. It is divided by 3. Three intervals have been splitted, no, and 3 intervals have been combined. So you have to find the answer in the splitted form. So it's divided by 3. You will be getting 6. Next here it's here also you can see that it's the two intervals are combined together, that is 60 to 70, 70 to 80. So you have to divide by 2. Then 4 divided by 2, that is 2 here. Next here you have to you just see any changes there. No. 80 to 90 single interval. Here 90 to 100 single interval. Then here there is no change in data. So next how will you plot? You can see here you have the marked 1 centimeter equal to 1 2 3 4 4 5 6 7 8 9 10 number of students, and here marks as 10 20 30 40 50 60 70 80 100 90 100. So how will you mark? As the same first two you can mark by plotting 5, the you can mark 5 here and mark a bar here. Then adjoining this you can mark another bar 10. Then you can mark another bar 20 to 34. Then when you mark 32 till 60, you have to mark 6. That is, it's equally divided 6. That is 30 to 46, 40 to 56, and 50 to 66. So it's equally divided. Then you can mark 6 here and you can expand the bar and mark it. So here 60 to 70 it's 2, 20 70 to 80 it's the 2. So adding both you will be getting 4. So you have to mark like this here. Then next note change 3 mark here like this. Then you can mark adjoining this. You can mark another, that's 9. That is how much? 90 to 100. Hope you understood the histogram in unequal class intervals. Next is frequency polygons, presenting of frequencies in the form of rectangles and joining the midpoints if the top side of the consecutive rectangles is known as frequency polygon. Frequency polygon curve is constructed with the help of discrete as well as continuous series. So how will you draw with the discrete series that you are going to see here? So the following data shows number of rows in 64 houses of a colony and construct a frequency polygon. So room number 1 2 3 4 5 6 and the number of houses is given. So how will you draw it? You are going to see here. First you have to mark just it's easy, 1 from 1 you have to mark 10 here. Then from 2 you have to mark 15 here. Then from 3 you have to mark 20 here. Then you from 10 you have 4 you have to mark 10 here. Then from 5 you have to mark 5 here. Then from 6 you have to mark 4 here. Then you have to mark the by joining from 0 you have to draw and by adjoining with scale you can just draw till 7. Till 7 you can mark, as it's a discrete series you have to mark till 7 and join. So this is discrete series. Next is continuous series. It's OUS. Okay, so you can see continuous series. The following is the age distribution of workers of a factory. On the basis of this, for information, construct a histogram and convert it into frequency polygon. So you can see it's a continuous series, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and the marks, the number of workers is given 15, 25, 7, 5, 2. So you have to first mark in the y-axis number of workers and x-axis the age. Then you can start from 20 here and mark a histogram, that's 15. Then from 30 here and mark histogram, that's 25. Next you can mark histogram as 40 to 57. Then 50 to 60 it's a 5. Then 60 to 70 it's a 2. Like that you can mark. And here you have to by how we will be marking this frequency polygon, just you have to see here, you have to join the midpoints and you have to mark here 0 to 10 to 20, here is 15. So here you have to mark. Then here this is the midpoint, then this is the midpoint, this is the midpoint, and this is the midpoint, this and here 70 to 80, here 75. At last, by joining the midpoints you will be getting the frequency polygon like this. Hope you understood this frequency polygon in continuous series. Next is frequency curve. The frequency curve is obtained by drawing a smooth freehand curve passing through the points of frequency polygon as closely as possible. So it's just drawing the frequency, it's just a freehand without scale. You can just join the midpoints and you can find the answer. So here 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60 is given. Here frequency 4, 10, 15, 18, 20, 16 is given. So you can just as it's starting from 0, you have to point you have to mark point before 0, that's point minus point 5 you have to mark here. Then start then you can just find a frequency 4 here. Then after marking histograms, that's 4, 10, 15, 18, 20, 16, you can mark with your free hand. First mark the midpoints here, and last at 65. After 60 you have to mark 65 as a midpoint. Then you can just by joining the midpoints with your free hand, you can draw the curve. So that's frequency curve. So hope you understood the frequency. Next one you are going to study is Ogive. So Ogive, you can just plot two columns, marks the number of students, and just write down the values. So Ogives you can maybe used for mainly finding the mid values like that. So you will be studying it the diagrammatic presentation of a cumulative frequency distribution is called Ogive, and less than cumulative frequency is there and more than type is there. So here we are going to see less than. So first you will be marking 10 as the less than frequency, that is less than 10, and next you will be marking less than 20, that is upper limit has to be taken here for marking this less than frequency. Okay, upper limit is 10, 20, 30, 40, you know. So next is less than 20, next less than 30, next less than 40. So this is the markings, and you have to just write the frequency here 5735. Then how will you find the CF? CF is 5, 5 plus this 7 you will be getting 12. Then 12 plus this 3 you will be getting how much? 15. Then 15 plus this 3, this 5 you will be getting 20. So always this 20 and this 20, the total will be same. So this is the less than frequency curve that you are going to see. So you it's always this like this you will be finding the CF. That's why the arrow has been put, and 20 and this 20 will be same. Then your answer is right, we can say that. So this is the less than frequency. How will you less than type of last frequency is equal to total. So that is to be noted. And next you will be studying more than type. So how will you find more than? More than type you have to find by just writing the this less than in more than type you have to take this 0, 0, 10, 20, 30. Okay, so you have to take more than 20. Sorry, more than 0 you have to write, and next more than 10. So this is upper limit is not taken here it's a lower limit for finding more than. So upper limit is taken for less than, and here more than type you will be taking the lower limit. Next is more than 10, then more than 20, then more than 30. So next you will be just writing the frequency as such. So frequency you will be writing for finding this, and it's 5735. So next how will you find this CF that you are going to see here? So in more than CF, first you have to write the total, that's 20. So from this 20 you will be subtracting each frequencies. So here 20 minus 5 it's 15. Next 15 minus 7 it's 8. 8 minus 3 it's 5. So you will be getting 5. So in the more than type last CF is equal to last frequency. So last frequency will be the last CF here. So here last CF will be the total. So that you have to keep in mind. Then you will be plotting the diagram. How will you plot? 0, 5, 10, 15, 20. So it is to be marked as scale, and then 20, 30, 40. So you, as you know, you will be marking more than now. So it's marks, then here frequency is there. And how will you mark the C? You will be marking highest 20, then will be marking next point, and you will be adjoining the values, and at last you have to mark the next one less than. So what is the value of less than? Less than is you will be you had a not written here, so you have to find 5, 12, 15, 20. So this is less than. Okay, so it's for your convenience to mark. So you will at 5 you are stopped here. Next you will be marking less than 5, 10, corresponding to 10 you will be marking 5, corresponding to 20 you will be marking 12, and corresponding to 30 you will be marking 15. Then adjoin this. Okay, then 40 you will be marking 20. Okay, so adjoining this 15 and 40, 20. So then you will be marking this point as the, what is this point, you will be marking this, you can find it as median. So this is the point where you can find the median. So it's 17 or 16 or 15. So we can't predict. So if it is graph, we can predict what is the actual value. So hope you understood what is ogive. Then another question, ogive or cumulative frequency curve. The curve obtained by representing a cumulative frequency curve or ogive. So that is known as S. So it's divided into two types, less than ogive and more than ogive. So from the following data, if a question is a distribution, monthly income of 60 people in a company, draw a less than frequency ogive. So how will you draw the less than frequency ogive? So you have to find at first the CF. CF is to be found, and you will be marking accordingly. So what is that? For less than frequency ogive, we will be marking 20, 30, 40 like that. Hope you understand. So how will you mark less than ogive? 20, 30, 40, 50, 60, 70. So 6, 15, 25, 40, 30, 52, 60 is the answer. So when you will be marking this, and after that you have to plot accordingly. So this is 8. Okay, so how will you mark? You can just see 6 is 20, then 30 is 15, then you will be getting this 40 is 25, then here 50 is 40, then 60 is 52, then 70 is 60. So you will be getting the answer by joining the points. You will be getting the less than ogive curve. Okay, so with the same question, how will you find more than? It's a 10, more than 10. The other side you have to take more than 20, more than 30, more than 40, more than 50, more than 60. Then 6, you have to first total it. So what is the total? So total is 60. Then you have to subtract the each frequency that is given corresponding to that. Then the answer will be like this. Hope you all will be getting the answer. Do it by yourself. Accordingly mark the point 60. Then 20 it's 54. Then 30 it's 45. Then 40 it's 35. Then here 50 it's 20, then here it's what's the answer? It's 55, that's 8. Okay, here 60 it's 8. Okay, this graph is somewhat it's moved like this, so you have to give, you will be getting the correct answer. Okay, see here you have to mark. So by joining these, you can just intersect both the curves. Joining these to more than ogive and less than ogive, you will be getting, you can draw perpendicular from this point downwards. You will be getting the median. So this is your median. So answer will be 45, I think. So it's your median. If anyone asks to find median with the help of ogive, so you have to just intersect both curves. Let's see, this curve has to be touched in 0 and this is to be touched in 60. So like that you have to 60, not 60, it's 70. Okay, so it has to be touched in 70. Then you have to draw the intersection point and find the median. Here it's, I think 45 is the median. Hope you understood. Next is arithmetic line graph or time series graph. An arithmetic line graph is also called time series graph. In this graph, time, hour, day, date, week, month, year is plotted along x-axis and the corresponding value of variable along y-axis. There are two types of arithmetic line graphs or time series graphs. One is one variable graph. One variable graph are those graphs in which values of only one variable are shown with respect to the same time period. So you can just see the data given below. Just see how it is plotted. One variable graph are those graphs in which values of only one variable is shown. As such, you can see here 2001, 2002, 2003, 2004, 5, 6 is given. Cement production is given 60, 90, 75, 80. 80, 95, 110. So you can just see the graph. It's just plotted with the raw data simply like this, and you can just plot 1 centimeter from here and mark 2011 in the x-axis, 2001 in the x-axis, and 1 centimeter again mark 2002 in the x-axis, then 1 centimeter 2003, then 2004, then 2005, then 2006. Here also you can just plot 20, 40, 60, 80, 100, 120. Then you can just plot from 2001, you can corresponding to that value is 60. You can plot say nearer to 60 as 60, and next is 90. You can plot 2002 and mark here 90, and 2003 you can mark here 75, 2004 you can mark here 80, and 2005 95, and 2006 110. So just to join this without joining the 0 point etc., and you will be getting the timeline graph. So it's known as time series graph in one variable. Okay, next is two or more than two variable graph. So the graphs in which values of two variables are simultaneously shown in respect to some period of time are two or more than two variable graphs. So the following table shows the values of imports and exports of a firm between 1991 and 2005. Present the information in the form of time series graph. So imports of raw materials 1998 1200, and exports of finished goods, you can see that 2200. Like that the datas are given here. You have to plot like that. You had plotted the one variable graph. So you can see the 1 and 2 imports and exports. So you can see the dot here, x-axis you have to mark years, and in the y-axis you have to mark imports and exports. So first you have to mark the 1200 here, then you will be marking 2200 here, then you will be marking like that each year wise you can mark. So 1998 like that you can mark, and you can plot and join the lines and mark this black line as imports and this dotted line as exports. And by plotting the same data, you will be getting the two variable time series graph. So only this much in this chapter to be studied. I think hope you understood. Thank you, students.